Hello, everyone, and I'm Robert Bulla, and I am the Director of Engineering and Innovation at APC Packaging. Just to tell you a little bit about myself, I'm a plastics engineer, and I've been in the plastics industry for about 27 years. And I've been involved in several sides of the plastics industry, from automotive, military, medical, and now for the last 8 or 9 years, packaging. We're going to talk about sustainability, and I borrowed from a fellow peer the term material wars and how materials are being marketed simplistically to protect one's own sandbox, as they would say. We will also address quickly what else besides the material do we need to consider when we approach a project with sustainable mindset, and how doing so can start to contain the misconceptions and bring about change. And the last time I spoke at this conference, I spoke about sustainable design, and I made it a point to show the definition of the word sustainability. As a refresh, here is the definition of sustainability: avoidance of the depletion of natural resources in order to maintain an ecological balance, the pursuit of global environmental sustainability. A rather simple concept that seems to create a lot of confusion. Many would quickly think of the damage created by the oil and natural gas industries right away. But notice in the definition, it says natural resources, as in the plurality of natural resources. Not just damage done from extracting a resource, but as well what that resource does when used to other natural resources, such as oceans, if not sustainably dealt with at its end of life. This is evident in the questions I get asked weekly. These questions are getting asked, in my opinion, because of many messages people are seeing, hearing about sustainability in the packaging industry. We as a society may have figured out it's far better for us in our home that utilizing our resources in a sustainable manner is a good thing to do, but there seems to be a disconnect on how to actually make this happen. The messages we receive can be good information, but many are displayed as if the problem of sustainability has already been solved. I consistently get asked which material is the most sustainable: glass, plastic, paper, or bioplastics. Here are two examples that start to explain why I get asked this very question. Based on this first example, PET is greener than aluminum. It tells the reader PET is the clear winner over all things aluminum, and you should only consider PET. The same goes for the next one, but instead of saying it outright, it implies this message via the stats compared between glass and aluminum. Are the stats and numbers shown wrong? And is this the whole picture? These examples plant a very deceptive seed and promotes the effect and idea that if you pick the right material, you can check the sustainability box done. Do we really believe a silver bullet in the form of a bioplastic, plastic, glass, or paper is available? The answer is no, and sustainability is not solved by just addressing the materials for packaging. Here's another example, although funny at first glance, and once again plants a seed that you cannot make a difference as an individual. It also shows that not everything is as it appears. Sustainability is a combination of good choices, from inception of attaining the resource to how the resource is recycled or dealt with at the end of life. The hyper focus on the material has caused some to be hyper partisan, when in fact most solutions presented today still have shortcomings that will need to be addressed regarding sustainability. It has taken a long time for the realization of a disposable society to hit home in so many ways that we do not need to marginalize efforts that are not perfect, but a willingness to try and continue trying to move the needle in the right direction. Let's look at a few of the materials: plastic, bioplastic, glass, and paper. Bioplastics. I want to make sure we are all speaking the same language, and I'm sorry to inform everyone, but bioplastics are plastic. Adding bio to the name does not take away the fact what they are referencing as bio really is plastic. There are many different companies offering some sort of bioplastic, but we need to understand what they are, how they work, and in many cases, they may contain multiple materials such as petroleum-based plastic, cellulose, or can only be industrial compostable or do not break down in water or a landfill. Bioplastics have advantages such as reduction in greenhouse emissions, potential to not impart harmful substances as they break down, and increase the possibility of using local resource. There are several disadvantages of bioplastics as well currently. To me, the largest is it creates competition for food sources. I want you to ask yourself if our population is disregarding proper petroleum based plastic recycling and littering our oceans and lands, how much faith do you have in a population that now hears bioplastic will dispose of this resource properly and do not harm the environment by clearing forest or overproducing a crop just to make more plastic, such as sugar or corn? Plastic. When I say plastic, I am meaning plastic derived from petroleum or natural gas. Is the most talked about due to how much we use plastic and how we dispose of plastic. We all know about the damage we have done to our oceans with plastic waste and how this affects our environment. Plastic is a resource we have overused and we as a people have not disposed or recycled properly. Plastics are not easily going to be replaced and may not need to be if we learn new ways to deal with issues we have created. There's a lot of research going on, and research on how to take this used resource and make it new again, removing the contaminants such as food and other things, is ongoing, and I have seen some great strides already being made. Plastics also have properties that are not easy to duplicate. Plastic and bioplastics are currently the same animal in many ways, and until we as a culture start implementing proper safeguards from inception to end of life, the problem will continue. Glass. Glass is spoken a lot due to its properties, but we are overproducing and taxing our environment, not only with the mining, but the effect of the mining for glass raw materials. We do not hear about ocean glass, do we? The reason, and this is key, the key is while glass is breaking down, it does not impart harmful chemicals back into the environment, causing harm. This is a key point when comparing glass waste to plastic waste and the effects on our environment. Paper. Paper is an unbelievable resource that will biodegrade the fastest of them all currently. Paper is widely recycled throughout the world. What we need to be aware of is the need for the main resource, which is cellulose, is not derived from deforestation. Paper, for our portion of the industry, has one major flaw, though. We have not yet overcome completely, and that is most beauty products have a percentage of water in the formulation. Paper has historically been coated with plastic for these situations that involve water being present. This can cause the paper to biodegrade at a much slower rate, but still far faster than any of the materials I've already mentioned. As well, the plastic that is used to coat the paper is minuscule when compared to a plastic bottle. In my last presentation on sustainable design, I discussed the need to consider not only incorporating recycled material, but designing for disassembly, recyclability, reuse or refill, sustainable decoration, material weight reductions, multifunctionalism, optimizing waste management, energy efficiency, transportation reductions. My next point is important. Take note that every consideration I just read and mentioned above does not mention an exact material or villainize another. It applies to all materials we are discussing. In addition, we need to understand what is and is not recycled and why. We also need to be aware of what is the intended consumer's relationship, not only with your potential product, but their relationship and perception of sustainability. Depending on the region your product will be released into, it can influence the consumer's perception of the product, how well it works, and their perception if your product is actually sustainable. These are just a few of the many considerations that need to be looked at in addition to the material chosen to move your package towards your sustainability goals. So how do we get to where we want to go? Once again, in the last presentation on sustainable design, I discussed the need to consider not only incorporating recycling, or excuse me, what do we need to know to put our best ideas to work besides choosing a material that is recycled? I have listed below just two of the several that I listed in the previous slide. Understanding ease of disassembly, understanding what decoration methods will be utilized and how this could affect recyclability. These are just a few of the many considerations that need to be looked at in addition to the material chosen to move your package towards your sustainability goals. As an example, we as a company recently worked on how to make a dropper closure recyclable for one of our newest patent pending innovations. We applied the same techniques we presented at the last Sustainable Summit by utilizing design intent and mind mapping. By mind mapping and having defined with clear intent our goals, we started the process and we will discuss a condensed version of two of these stages. Stage one, identify the current composition of the package or the product and current ability to be recycled. Droppers used in the beauty industry are typically comprised of the following as we break it down. The bulb is made from silicone or nitrile, which are both thermoset plastics. Thermoset, as in a car tire, is a thermoset plastic. This means once the material has been cured, it can never be ground, melted, and converted again. These materials cannot be recycled as we understand with paper, glass, and thermoplastics. The dropper collar is typically made from polypropylene, which can be recycled under Recycle Code 5. Pipette is typically made from glass, but we've also seen PETG, SAN pipettes, which are not recycled. With the package having multiple materials with some not being recycled, we hit our first roadblock in our goal of sustainable dropper. What if we apply ease of disassembly, which is where the consumer can easily take it apart? A jar and a cap is a good example of ease of disassembly. Since we determined the bulb needs to be separated from the other two possible components for recycling, let's say for simplicity's sake, all three parts come apart easily and we have three individual parts. We discard the silicone or nitrile bulb since we determined the bulb will not be recycled. This leaves the collar and the pipette. The PP collar is made from recycled material, but do we stop here? No is the answer. In this case, a rule concerning ease of disassembly was used to get the PP collar part to a recyclable state. But another recycling rule now comes into play since the part is now in a possible state to be recycled. The rule the PP collar runs into is the part is not large enough to be recycled. Typically, a 2x2 or 2-inch by 2-inch test separates parts that are too small to be recycled. Next, if we look at the pipette, if made from soda lime glass, will depend on the area you're looking to dispose of the used pipette and its recyclability. If a pipette is SAN or PETG, as we had discussed before, it will not be recycled and more than likely will end up in the landfill. At best, we end up with maybe one, maybe two parts that can be recycled. Stage 2. To take the next step, we internally had a mind mapping session where we laid out all concerns, expected requirements, and our ideas related to each main subject we designated, such as how will the customer interact with it, ease of use, recyclability, length, aesthetics, so forth. All of these things were mind mapped, categorized, and laid out. When we broke down each component, we decided ease of disassembly will not fix or achieve our recycling goal per stage 1, and we needed to see how to address the following. How can we be monomaterial and pass small parts tests since separation of the components results in failure? How do we make a bulb as soft as nitrile or silicone but still have the recyclability and chemical resistance and still be monomaterial? The dropper collar must stay in PP, we decided, and it has to also not have issues with compatibility. The pipette must be clear as PET, but still have the chemical resistance required. In doing this exercise, we found solutions for each and every one of the problems, and we found solutions for each one that we listed above. But how did we do it? APC has defined innovation and sustainability and follows a predefined path for designing for sustainability. This applies as well for packaging engineers. How do you approach a project when you want it to be sustainable? Our process promotes not just thinking in the box, but outside it as well. And we discovered new ways to make PP as clear as PET, and we leaned on our material knowledge for how to soften a bulb but still be recyclable and have an entire package that did not need to be disassembled and met all the other rules that we were running, that the other dropper ran into. These steps I went through, yes, was for a monomaterial plastic part, but these steps do not just apply to plastic. They apply to all materials and the parts or packages we innovate. Moving on, if we look at the next item I listed, which was understanding what decoration methods will be utilized and how this could affect recyclability. This is an area where some brands have struggled with bare recyclable packages in maintaining or introducing a new look through deco and how it affects the recyclability. I want to point out once again, the question of recyclability does not only revolve around the material chosen. As an example, VM or vacuum metallization, large coverage with hot stamp foil, soft touch spray, large coverage PS labels, optical brighteners, all have negative effects on the recyclability of the final package. VM and hot stamping deposit and bond aluminum to the part. Metal contamination can have a negative effect all through the recycling and conversion process. Soft touch and large coverage PS labels contaminate the feed stream. Optical brighteners, which are awesome, are great for getting PCR colors to pop, but they result as well in feed stream contamination. Another consideration is weighted packages. Weighted packages are typically done by inserting a steel weight into the package and most likely gluing in place. The weight can give a feeling of quality of the package and a product, but once again, even if the material is glass, paper, or bioplastic, would fall under not recycled because now we have multiple materials that cannot be easily separated. All of these issues bring about innovation by innovating new ways to achieve the goal of sustainability. So what is happening in the industry regarding sustainable decoration? Soy-based inks for silk screening. But one thing that needs to be kept into consideration with soy-based inks is they are not as chemical resistant, and typically a UV top coat would need to be applied. LED cured silkscreen inks that can be cured as quick and utilizing a lot less power. And they also have the ability to actually cure white inks completely through versus the typical UV iron dope bulb. Also, there's laser marking additives that allow for a lot more than just a dot matrix look for lot numbers and dates are just a few of the many innovations helping in the industry. In conclusion, materials are important choices, but as we have discovered or discussed, are not the only ones we need to consider for sustainability. Material wars over which is better oversimplifies the message that sustainability is a single question that can be answered by just a material choice. Sustainability is about a succession of many good choices made along the life cycle from inception to the end. Just want to tell everybody, please make sure to check out my packaging blog at apcpackaging.com. And now I'll open it up to questions from everyone.
Hi, Robert. It's Amajit here, the moderator. We're short of time, so we're going to have to close this, and we're going to restart again in about 15 minutes. But I would like to encourage all of you to visit the exhibitors, including APC Packaging, in the exhibitor room. So if we leave this session now, and then we can join the exhibitors, and feel free to send your comments and questions directly to Robert because we're out of time. Thank you, Robert.
Thank you, everyone. I appreciate your time.